Welcome to Coagulation Cascade, the making of a strong fibrin clot. In this video, our focus is on step 2, clot propagation. Over the next few minutes, we will be focused on the following take-home points. During clot propagation, the intrinsic pathway generates thrombin. Thrombin amplifies clot propagation by activating fibrinogen to fibrin and also activating factors 5, 8, 11, and 13. The process of clot propagation occurs in the presence of calcium on the platelet phospholipid bilayer. We have previously learned that the first step of the coagulation cascade is initiation, a process in which we activate the extrinsic pathway in which tissue factor 7 form a complex to activate factor 10A. Factor 10A in turn works with its cofactor 5A to generate thrombin in small amounts. In this video, we will be focused on clot propagation, in which we activate the intrinsic pathway and generate thrombin in large amounts. We will learn that the extrinsic pathway also activates the intrinsic pathway, and by generating thrombin in small amounts, we also activate the intrinsic pathway. All this thrombin that is generated acts in a feed-forward loop to generate additional thrombin in large amounts. Now, let's focus on the steps of clot propagation. Let's discuss the process by which the extrinsic pathway also activates the intrinsic pathway. The extrinsic pathway factors, tissue factor and factor 7A, also activate 9 to 9A. Now let's focus on 9A. 9A has as its cofactor 8A, which works to help factor 9A activate 10 to become 10A. 10A also has as its cofactor 5A, which works to activate prothrombin to thrombin. Factors 8 and 9 are key factors in the intrinsic pathway. Now, the intrinsic pathway is also known as the contact activation pathway, which is triggered by the action on contact surfaces by factor 12. Factor 12 is activated by the factors prekallikrein and high molecular weight kininogen, which activate 12 to 12A. Then 12A with its cofactor, high molecular weight kininogen, act on factor 11 to activate it to factor 11A. Factor 11A in turn acts in the presence of calcium to activate factor 9 to 9A. Then we're familiar with the rest of the process where factor 9's cofactor, 8A, helps activate 10A, which acts in the presence of 5A to activate thrombin. These factors, prekallikrein, high molecular weight kininogen, and factors 12, 11, 9, and 8 all make up the intrinsic pathway, which generate a significant amount of thrombin. Now we will learn how amplification of thrombin generation occurs because thrombin not only activates fibrinogen to fibrin, but also activates factors 5, 8, 11, and 13, which further propagates the fibrin clot. The fibrin clot is propagated as long as thrombin acts on fibrinogen to convert to fibrin, and then fibrin and fibrin come together to form fibrin polymers. And fibrin polymers get cross-linked by factor 13. Now, let's bring in the extrinsic pathway and the intrinsic pathway. Focus now on factor 11. Prothrombin acts on factor 11 to activate it to factor 11A, and this allows 11A to activate 9A. Next, focus on factor 8. Thrombin acts on factor 8 to convert it to 8A. This allows it to activate 9 to 9A. Next, focus on factor 5. Thrombin activates factor 5 to 5A, which allows it to work as a cofactor for 10A. Now let's focus on factor 13. Thrombin acts on factor 13 to activate it to 13A. This allows 13A to successfully cross-link fibrin. By activating these factors, additional thrombin is generated, thus continuing the process of clot propagation. Now let's focus on a smaller positive feedback loop in which factor 10 also activates 7 and 8. Let's go back to clot propagation and focus on factor 10. Factor 10 activates 8 to 8A. Factor 10 also acts on factor 7 to convert it to 7A. That ends the smaller positive feedback loop of factor 10. Now let's bring in the rest of the intrinsic pathway with factor 12 being activated to 12A, which in turn activates 11 to 11A. Note that various parts of clot propagation act in the presence of calcium, and all of this process is occurring in the presence of phospholipids. These phospholipids come from the phospholipid bilayer of the platelet. The platelet is identified here in purple. This is the essence of clot propagation, which will continue until we activate antithrombotic mechanisms to stop thrombin generation. Let's recap. In step 1, we started with clot initiation, in which we activated the extrinsic pathway to generate thrombin in small amounts. This process led us to the second step of clot propagation, in which we activated the intrinsic pathway, allowing us to continuously generate thrombin in large amounts. The third step in this process is clot termination, in which we activate antithrombotic mechanisms to stop thrombin generation. To this end, our next video will focus on step 3, clot termination. To summarize, we learned the following points. During clot propagation, the intrinsic pathway generates thrombin. Thrombin amplifies clot generation in a positive feedback loop by converting fibrinogen to fibrin and activating factors 5, 8, 11, and 13. Clot propagation occurs in the presence of calcium on a phospholipid bilayer. This ends the video in which we learned about step 2, clot propagation, of the coagulation cascade as we advance towards making a strong fibrin clot.